In this video, I will show you how a pressure relief valve works. This is an important valve as it limits the pressure on the hydraulic system and acts as a safety valve. You will find at least one of this type of valve on all hydraulic systems. I'd say it's a relatively complex valve, but it's important to understand how it works. The valve is regulated mechanically with a compression spring. What makes compression springs useful for this purpose is that they become stronger the more they are compressed. I can show this with a simple demonstration. I will use two masses to illustrate, one larger than the other. Now, if I put the small mass on the spring will compress just enough to be strong enough to lift the mass. If I put the larger mass on the same spring, you will observe that the spring is more compressed. With this level of compression, the spring is stronger and is able to lift the larger mass. This principle is used to regulate many mechanical processes. Now that you have this fresh in your mind, it will be easier to learn how a pressure relief valve works. This is a simple sketch of a pressure relief valve in its simplest form. It will always have an inlet where oil flows into the valve and an outlet where oil leaves the valve. The inlet is connected to the pressure side of the hydraulic system, while the outlet is connected to the hydraulic tank. There is an adjustment screw that will compress the spring and make it stronger when screwed in, and conversely decompress the spring and make it weaker when screwed out. The spring pushes a cone, or a poppet, that in turn is pressed against the valve seat in the body that closes the valve. When you start the hydraulic system, pressure starts to build up. This pressure creates a force when working in the area of the valve cone. The force will increase with higher pressure. The force made by the hydraulic pressure will try to open the cone. On the other side, you have a spring force that is trying to hold the valve closed. There will always be a contest between these two forces that will determine if the valve stays closed or open. When the force from the hydraulic pressure prevails, the valve will open and oil will flow to the tank. When oil leaves the hydraulic system, the pressure on the entire system will decrease and the valve will once again close. In this way, the valve will open and close in order to maintain even pressure in the hydraulic system. This pressure will be the pressure that is needed to compress the spring and open the valve. To increase the pressure on the system, we need to compress the spring with the adjustment screw to make it stronger. The system then needs higher pressure to open the valve. If you want to decrease the system pressure, you will need to make the spring longer and weaker by turning the adjustment screw outwards. This is the simplicity of the principle. Adjust the spring to make it longer or shorter and thereby stronger or weaker in order to increase or decrease the system pressure. This valve is a simple variant of a pressure relief valve. One problem with this type of valve is that you need to keep the area in the valve inlet small, which means you need to avoid using a large spring. When the inlet opening is small, the valve will not be able to handle large flows, but it is suitable for a small hydraulic system. On a large hydraulic system, the relief valve must be able to handle greater flow in order to have complete control of the maximum pressure in the system. For these systems, we can use another direct working valve design, or a piloted relief valve. I will make a separate video to explain the piloted relief valve. What you see here is a more advanced pressure relief valve. However, it is still a direct acting valve. It also has an inlet connected to the pressure side and an outlet connected to a tank. It also features a spring and adjustment screw, but the cone is replaced with a valve slide. Oil enters this chamber in the valve and the pressure works in the area surrounded by these two rings. They are similar and work in opposite directions, so this pressure will have no effect on the force against the spring. The pressure will also go through this signal port here and act on the whole area below the valve slide. As there is no pressure above the slide, the pressure difference will try to lift the slide upwards. To make the slide move freely, it is made slightly smaller than the valve body. This will cause a tiny internal leak, but a few drops of oil going from the pressure side to the tank side makes no difference. When the force created by the pressure working on the area below the slide overcomes the force from the spring, the slide will move upwards. The valve will then open and allow oil from the hydraulic system to flow to the tank. As with the earlier example, when oil leaves the system, the pressure will be reduced and the valve closes again. This way, it will make sure that the maximum pressure adjusted by the adjustment screw is not exceeded. The adjustment of the valve works in the same way as the first valve. Compress the spring to make it stronger and the pressure will increase, or conversely decompress it to make it weaker so that the pressure will decrease. This small port you see here is a drain port. As these slide valves are not drip tight, oil will leak past the slide and fill the chamber above it. This type of valve needs a drain to let oil out when the slide is moving upwards. If not, the trapped oil could stop the slide from moving freely. That's how a direct acting pressure relief valve works. The pressure relief valve sets a maximum pressure on the whole system. If you want to reduce the pressure on parts of the system, you need to use a pressure reducing valve. A separate video covering this is available. This is the valve symbol, which is part of the ISO standard, and, as you can see, it has a logical structure. The arrow inside this square illustrates the direction of flow through the valve. This means that the valve inlet is on the left side on this symbol, and the outlet is on the right side. This dotted line goes from the pressure side to underneath the slide. This line represents this signal port inside the valve, and it also shows that the valve is measuring the pressure before the valve. Dotted lines in hydraulic flow charts, or P&IDs, are signal lines. When the pressure on the system increases, the pressure will be channeled to below this arrow that symbolizes the slide and push it up. When the arrow is not in line with the inlet and outlet, like this here, it means that the valve is normally closed and you will need some kind of action in order to open it. Above the valve symbol, we have the symbol of the spring that is always trying to close the valve. The elevated arrow over the spring tells us that the spring is adjustable. These elevated arrows are used on all adjustable components in hydraulic P&IDs. Knowing the functionality of the valve will help you when reading hydraulic P&IDs, even if the symbol is structured logically.